Hello, my name is Pooja, and today I'm going to explain the medical charges insurance project that I worked on. This project involved analyzing insurance cost based on various factors like age, gender, BMI, and the smoking habits. Throughout this project, I performed several key tasks to understand the patterns and provide meaningful insights. Let me take you through each task one by one. Task 1. Task 1 is basic statistics and data understanding. In the first task, I explored the basic statistics of the data set to understand the structure of the data. This includes analyzing the average, median, and standard deviation of age column, which gave me insights into the distribution of ages in the data set. To calculate the average age, I used the formula equal age and the age column, as you can see in the formula bar, and for the median age I use the formula equal median and the age column, as you can see here. And to find the standard deviation, I applied the formula equal STDEV, standard deviation, and the age column. So these basic statistics helped in understanding the central tendency and the spread of ages in the dataset, giving a foundation for further analysis. This gave me a clear view of how the data is distributed and where the variations lie. So my task 2 is for gender analysis. In this task, I analyze the difference in medical charges and BMI based on gender. I started by creating a pivot table to calculate the average medical charges and average BMI for both male and females. This gives me a clear comparison of how medical cost and BMI vary by gender. To make the data more interactive, I added a slicer that allows users to filter the data by selecting either males or females, like this. This slicer helps visualize the data for each gender separately, making the analysis easier to interpret. Additionally, I created a donut chart here to visually represent the medical charges for male and female. The donut chart shows that there is very little difference between the average medical charges for both genders. These combinations of a slicer, pivot table, and donut chart allowed me to explore gender differences in medical costs and BMI in a clear and interactive way. So let's move on. Task 3, and task 3 is impact of smoking on cost. So here I analyzed the impact of smoking on medical charges. I used Excel functions, pivot tables here, and chart here. To compare the average charges for smokers and non-smokers. The results were clear. Smokers had significantly higher medical charges than non-smokers. You can see the difference. This is for smokers and this is for non-smokers. Yes represent the smoker status, yes, and no represent the non-smokers peoples. So this aligns with expectations, as smoking is a non-risk factor for many health issues. And task 4 is dependent analysis. In this task, I focused on analyzing the medical charges based on the number of children in the data set. To do this, I created a pivot table that summarized the medical charges according to the number of children. Each individual had After setting up the pivot table, I generated a chart to visualize this data. The chart clearly illustrates that the values for individuals with 1, 2, 3 and 4 children, you can see, are almost the same. This indicates that the number of dependents does not significantly impact the medical charges in this data set, suggesting that other factors may play a more critical role in determining medical cost. So let's move on towards the task 5. Task 5 is geographical insights. For this task, I focused on regional differences. I used a pivot table here to group the data by region and calculate the average medical charges for each regions. You can see. This allowed me to identify which regions had the highest and lowest medical cost. It turned out that some regions, west regions, you can see, west regions, northwest and the southwest had significantly higher cost. Let me sort it, largest to smallest. It turned out that some regions, east regions, had significantly higher cost than others, possibly due to healthcare access differences. To visualize this data, I used a bar chart which displays the charges for each region. In addition, I also created a pie chart to show the proportions of charges contributed by each area, which can inform regional healthcare strategies and resources allocation. So, task 6 is cost distribution analysis. In this task, I analyze the distribution of medical charges to understand spending patterns among the data set. To do this, I created a histogram which visually represents the frequency of medical charges across different ranges. These are the ranges. Upon examining this histogram, I found that the values in the range 1000 to 15,000, 1000 to 15,000 from here to here had the highest frequency. This indicates that a significant number of medical charges fall within this range, suggesting that most patients incur costs that are relatively moderate compared to extreme values. Overall, the cost distribution analysis provided valuable insights into the financial landscape of medical expenses. So my next task is for BMI classification. In this task, I classify individuals based on their BMI into categories such as underweight, normal, overweight and obese. I then calculated the average medical charges for each category. As expected, individually in the obese category had significantly higher. I sort it from largest to smallest, so you can see obese category has higher medical charges, which again tie back to health risk associated with higher BMIs. My task 8 is advanced correlation analysis. In this task, I aim to explore the relationship between medical charges and BMI. To do this, I created a scatter plot with medical charges on the y-axis here and BMI on the x-axis to visualize any potential trends or patterns between these variables. After examining this scatter plot, it was clear that there wasn't a strong relationship between BMI and medical charges. The points were scattered without forming any visible trend. indicating that BMI doesn't directly influence the medical cost significantly. To further confirm this, I calculated the correlation coefficient. You can see the formula in the formula bar for calculating this correlation coefficient between these two variables. The result was 0.198341, which is quite close to 0. This indicates a weak relationship, meaning that as BMI increases, medical charges slightly increases, but this relationship is not strong enough to be statistically significant or meaningful. So this finding suggests that BMI alone might not be a key factor in determining medical cost, and that other variables such as smoking status or the number of dependents could have a more significant impact on charges. And my task 9 is for smoking regions. In task 9, I focused on analyzing the interaction between smoking habits and region. To do this, I created a pivot table that summarized the number of smokers across different regions. You can see. I then added 2 slicers for more interactive analysis. One slicer for smokers with options yes or no, allowing the data to be filtered based on smoking status. Another slicer for regions, so the data can be filtered by geographical location. By using these slices, I was able to observe a clear trend. Southern region, you can see here, southern regions, number of smokers compared to southern regions have a higher number of smokers, because this yes value represent the smokers. And let me sort it largest to smallest. So the southern regions have a higher value of number of smokers compared to the northern regions. This insight is useful for understanding the geographical distribution of smoking habits, which could help target health interventionally more effectively in areas with a higher prevalence of smokers. So let's move on to our dashboard. To wrap everything up, I created a dashboard that presents the key findings in an interactive and visual format. The dashboard includes charts, graphs showing total charges in these kind of cards, the impact of smoking, regional differences, and other key metrics. Stakeholders can use filters like this. Let me remove the filters. So stakeholders, you can use filters to look at specific regions or groups. In conclusion, this project provides a deep understanding of the factors that influence medical charges. Smoking is the major contributor to higher cost, while other factors like gender, BMI, and number of dependents had less impact. The insights gathered can help insurance companies make informed decisions regarding premiums and risk assessments. So thank you for listening, and I hope this explanation had provided a clear overview of the medical charges insurance project. Thank you.